Hello there, and welcome to Midnight Lab, where curiosity slows down enough to fall asleep beside it, and even the strangest objects in the universe become gentle company for the night. Tonight, you and I are going to drift towards something that has frightened, fascinated, and puzzled people ever since we first imagined it. Not a monster hiding in the dark, not a disaster waiting to happen, but something much quieter. A place where gravity has gathered itself so completely that even light cannot quite find its way back. We're going to spend the night with black holes. Not as villains, but as silent oceans in the fabric of space-time. Deep, still wells in the universe that simply exist patiently while everything else moves around them. Before we begin, take a moment to notice where you are. Is it late evening where you are, or the kind of midnight that already feels halfway to morning? Are you lying in bed, lights low or off, with a dim clock or small screen, glowing quietly somewhere in the room? Or maybe you're sitting, head resting against something soft, eyes a little heavy, telling yourself you'll just listen for a minute and then turn this off, but secretly knowing you might stay here longer. Wherever you are, and whatever time is staring back at you in tiny glowing numbers. You don't need to do anything for this to work. You don't need to concentrate. You don't need to remember details. You don't need to understand every idea. You are completely allowed to drift in and out of this story. You can follow along for a while, then let your thoughts wander, then come back later, without ever feeling lost. The universe will keep going. The story will keep flowing, even if you fall asleep halfway through a sentence. If you find this journey calming or comforting, or simply a gentle way to let your mind step out of daytime worries, I'd be very grateful. If you subscribed to Midnight Lab, and perhaps left a quiet like on this video, it helps this little corner of soft-spoken science reach more people who are awake at impossible hours, looking for a peaceful night among the stars. Now, take a slow breath in and let it out, without rushing. Feel the weight of your body, wherever it's resting. You don't have to relax perfectly. You don't have to stop every thought. You just have to not hurry. Tonight, we'll walk together through gravity, through the lives and deaths of stars, and through the quiet depths of black holes. Slowly enough that your mind has time to soften, and your imagination has room to wander. Gravity, gently. Right now, there is an invisible pull, holding you against the bed or chair beneath you. We call it gravity, as though it were a single simple thing. In school, we learn that gravity is a force, pulling objects toward each other, and that's a good enough picture for everyday life, for dropped keys, for falling raindrops, for your feet staying on the ground. But the universe is not offended by our simple explanations. It just keeps doing what it does, quietly, whether or not we fully understand it. In the deeper picture, gravity is less like a mysterious hand, pulling from far away, and more like a gentle curve, in the place where everything happens. Space and time are woven together into a single fabric, space-time. And wherever there is mass or energy, that fabric bends. If that feels abstract or slippery, you don't need to hold onto it too tightly. You can imagine something simpler, a soft sheet stretched out in front of you. If you place a small marble on it, the sheet dips just a little. If you place a heavier ball, it dips more deeply. Now imagine rolling another marble nearby. It doesn't feel a hand pulling it. It just follows the curves in the sheet. In a loose, sleepy way, that's what gravity does. Mass tells space-time how to curve, and space-time tells matter how to move. The Earth curves space-time around it, and the straightest path in that curved space happens to lead downward toward the ground. Your bed pushes back and you stay where you are. You don't need to picture it perfectly. It's enough to know that where there is mass, there is a gentle bending of the universe. And somewhere, that bending becomes so deep, so steep, that even light cannot climb back out. That is where black holes live. How stars are born, live, and die. Before we drift all the way into those deep wells, we need to follow the long, slow lives of the stars that create them. Because black holes do not appear out of nowhere. They are the final chapters in the stories of very massive stars. Far away, in the thin, quiet spaces between stars, there are clouds of gas and dust. Not thick clouds, like the ones you see in the sky, but vast, delicate veils, stretching across light years, mostly hydrogen, with traces of other elements, spread out like a faint, cosmic mist. These clouds are not truly still. Gravity is always present, even when it feels weak. Tiny regions, a little denser than their surroundings, begin to pull in more material. Slowly, over millions of years, a clump grows. It contracts, densifies, and at its center, the pressure and temperature rise. You can imagine a region of the cloud quietly gathering itself, getting smaller, warmer, more compact, like breath condensing on a cold window pane. Eventually, in the core of that shrinking clump, conditions become just right for something remarkable. Hydrogen atoms begin to fuse. They join together, forming helium and releasing energy. A star has been born. From great distance, it appears as a tiny point of light. Up close, if we could ever be close, without being burned away, it is a roiling, radiant sphere of hot gas held together by its own gravity, glowing because its core is quietly turning mass into energy. For many stars, this phase lasts a very long time. Smaller stars can burn steadily for tens or even hundreds of billions of years. Our Sun, a medium-sized star, will calmly fuse hydrogen for around 10 billion years in total. It is not even halfway through that main part of its life. Massive stars, though, live faster. Imagine two candles, one thin and steady, the other thick and blazing. The brighter candle burns its wax more quickly. In a similar way, the most massive stars burn through their fuel at a furious rate. They shine intensely, beautifully, but briefly, on cosmic timescales, at least. Inside these massive stars, the core changes with time. Hydrogen fuses into helium. When the hydrogen runs low, the star adjusts and helium begins to fuse into heavier elements, carbon, oxygen, and others. Step by patient step, the star builds up layers of different elements, like the layers of an onion, made of fire. But there is a point where this process reaches a limit. When the core becomes mostly iron, fusion stops helping. Instead of giving off energy, fusing iron consumes it. The outward pressure that held gravity in delicate balance weakens. Gravity, which has been patiently there the whole time, finally has its chance to pull inward without opposition. The core collapses. In an unimaginably short time, the star's inner regions fall toward the center. The outer layers crash down, rebound, and explode outward in what we call a supernova. From far away, this looks like a sudden flare, so bright it can outshine an entire galaxy. For a brief period, it sounds dramatic, and it is, but it's also just the universe, continuing its long, gentle habit of turning one form of structure into another. What remains after that explosion depends on how massive the original star was. Sometimes a dense compact object, called a neutron star, remains, a city-sized sphere, with a mass greater than the Sun. But if the original star was truly enormous, even this dense remnant cannot hold itself up. Gravity continues inward. There is no new kind of pressure strong enough to stop it. Matter collapses toward a point, and space-time around it curves so steeply that all paths lead inward. A black hole has formed, not as a burning wound, not as a screaming void, but as a final, quiet state of overwhelming gravity. The star's long, bright life ends in a tiny, silent region where light itself cannot escape. The event horizon, the quiet edge. To imagine a black hole in a way that's friendly to a sleepy, wandering mind, it helps to picture a shoreline at night. There is a moment where sand stops and water begins. From a distance, the line between them looks simple, almost sharp. But if you stand there at the water's edge, there is no exact step. When dry becomes wet, there is a gentle zone where the waves come and go, sometimes touching your feet, sometimes retreating, never quite the same. From one moment to the next, around a black hole, there is an invisible boundary called the event horizon. It is not a wall. You would not bounce off it if you somehow approached. It is more like that edge between dry sand and water, a surface in space-time, where something subtle but important changes. Outside the event horizon, it is still possible, in theory, to escape the black hole's pull, if you have enough energy. Inside the horizon, no path exists that leads outward. Every possible future takes you deeper in. To someone watching from far away, objects falling toward the horizon seem to slow down. Their signals stretch into redder and redder light, weaker and weaker, until they fade out entirely. It appears as though they never quite arrive, hanging forever at the edge. From the object's own point of view, time feels normal. It crosses the horizon without noticing any special line. The strange part is not what it feels, but what the universe outside can no longer know. You don't have to wrestle with the details, especially not at this hour. Instead, you can simply imagine a dark ocean with a surface so calm, so deep, that anything crossing it can only move inward. From the shore, we see ripples vanish, stories that continue out of sight. That's enough for tonight. A softer look at the center. Deep in the center of a black hole, our current equations predict something called a singularity, a place where density and curvature become infinite, a word that mostly means. Our math breaks down here. It's tempting to imagine a single point containing everything, but reality may be more subtle than that. We do not yet know what truly happens at the very core. Future theories might reveal a softer, more complete picture. For now, it is perfectly fine to say, "We're not sure," and leave it there. You are not failing if you don't fully grasp what a singularity is. You are not behind. Even the most advanced scientists in the world are still trying to understand it, and they need years, equations, and entire teams. Tonight, your only job is to let this idea float by like a cloud passing overhead that you don't need to chase. Different kinds of black holes, same quiet. Black holes come in different sizes, but they all share that same deep stillness. Some are formed from single massive stars. These stellar black holes may have a few times the mass of the sun, or a few dozen times. They might quietly orbit another star, pulling a little gas from it, forming a glowing disk of matter, spiraling inward. Others grow much, much larger. In the hearts of many galaxies, including our own, are supermassive black holes, millions or billions of times more massive than the sun. At the center of the Milky Way is one of these giants. It does not rampage through the galaxy. It does not suck everything in, like water swirling down a drain. Most of the time, it simply sits there, curving space-time around it, while stars orbit in vast, elegant paths like fireflies, circling an invisible campfire. Right now, as you lie still, you are part of that orbit. The Earth turns, the Earth circles the Sun circles the galactic center, and the galactic center holds a black hole. We cannot see directly, but whose presence we can feel in the motions of stars. You don't feel any of it. You feel your pillow, your blanket, the gentle weight of your own body. But beneath that quiet, gravity is busy. On unimaginable scales, and black holes are simply part of that vast, slow dance. What we actually see. By their nature, black holes do not send light out to us. So how do we know they exist? We watch what they do to the things around them. When gas and dust fall toward a black hole, they rarely fall straight in. They swirl, forming a disk, rubbing and colliding, heating up, glowing. Sometimes that glow becomes intense, bright enough to be seen across huge distances in the universe. We also watch stars near the centers of galaxies, seeing them whip around in tight, fast orbits. That can only be explained by a massive dark object at the center. Using telescopes spread across Earth, astronomers have even built images of the shadow of a black hole, a dark center, surrounded by a glowing ring of material. It looks like a silent eclipse against a bright halo, a hole in the light. You don't have to remember how those images were made. You can just hold on to the picture of a soft, dim ring of light, embracing a perfectly black circle, a place from which no light returns. Time stretched and softened. One of the most dreamlike things about black holes is what they do to time itself. Where gravity is stronger, time flows more slowly, compared to regions with weaker gravity. On Earth, this effect is tiny, but real. Clocks on mountains tick just a little faster than clocks at sea level. Your phone does not notice, but physicists can measure it. Near a black hole, the effect becomes dramatic. Imagine someone hovering safely far away with a very precise clock watching another clock fall toward a black hole. From afar, the falling clock appears to tick slower and slower. As it nears the horizon, it signals more stretched, its light more red. To the person holding the clock, though, their own time feels ordinary. They think, they breathe, seconds pass, as they always have. It is only when these two perspectives are compared that the strange difference appears. If all of this feels slippery, you do not need to tie it down. You can simply think of the universe as a place where time is not rigid and uniform, but a little bit flexible, a little bit gentle, responding quietly to gravity's presence on days when you feel that time is chasing you, racing through schedules and alarms. It can be oddly comforting to remember that in much of the universe, nothing is in a rush. Stars change slowly. Galaxies evolve slowly. Black holes wait patiently. The universe is in no hurry to get anywhere. You don't have to be either, at least not right now. Black holes and the far future. Far, far into the future. Long after your life. Long after our civilization. Long after the last familiar stars have burned their fuel. Black holes are expected to still be there. As the universe ages, bright, young stars will give way to dimmer, older ones. New stars will form more slowly. Galaxies may collide, merge, and reshape themselves. Eventually, the night sky may look very different from how it looks today. And in that distant future, black holes, especially the largest ones, may be among the last prominent structures remaining. There is a subtle process, predicted by our best theories, through which black holes can slowly lose mass over incredible times, radiating tiny amounts of energy. For a black hole with the mass of a star, this would take longer than the current age of the universe, by a factor so huge that the number barely fits in the mind. For a supermassive black hole, the timescales are even more vast. You do not have to picture it. You don't need to imagine the universe that far ahead. It is enough to know that black holes are not just curiosities of the present moment. They are part of the deep future, slowly, quietly shaping how the universe's story unfolds. And somewhere in that story, for a brief, flickering chapter, there is you, lying in a dark room, listening to a voice describe these things As you drift toward sleep, your place in all of this, it's easy to feel small and fragile compared to black holes, galaxies, and the vastness of space. And you are small, physically, on cosmic scales. But small does not mean unimportant. Your body is made of atoms, forged in stars. The iron in your blood came from ancient stellar furnaces. The calcium in your bones was built in the hearts of stars and scattered into space by long-vanished explosions. The oxygen you breathe was manufactured by stars that lived and died billions of years ago. The same universe that curves space-time so deeply that light cannot escape also shaped you out of its own materials. You are not separate from the cosmos. You are a tiny, beautiful expression of it. When you feel overwhelmed by your day, by work, by worries, by the things left undone, it can help to lift your perspective gently. From far enough away, those worries shrink. They don't disappear, but they soften. They become small ripples on the surface of a much larger sea. Tonight, this story is not here to solve your problems or erase them. It's here to give your mind a softer place, to rest for a while so that your body can do what it knows how to do, to breathe, to restore, to sleep, drifting away. As we come to the gentler end of this journey, you might take one more moment to notice the details of the space around you, the feeling of fabric against your skin, the way your body sinks into the mattress or chair, the temperature of the air on your face, any faint sounds, a distant car, a soft hum, the subtle noise of your own breathing. Above you, whether the sky is visible or not, the galaxy stretches out. At its center, a supermassive black hole waits in silence, curving spacetime into a deep, still basin. Far beyond, other galaxies turn, some with their own central giants. Light from distant places crosses the dark, passing near these silent oceans and gently bending around them. You do not need to hold any of these images perfectly. You can let them fade as soon as they arrive, like dreams that you don't bother to write down. If sleep is close, you can let it come. If your thoughts are still wandering, you can simply stay here, floating beside this idea of black holes as quiet places, not monsters, not threats, just deep, patient shapes in the universe. You are allowed to forget everything you've heard tonight. You are allowed to let your imagination drift wherever it wants to go, to other worlds, to distant stars, to peaceful scenes. From your own memories, the universe will keep moving, keep expanding, keep curving space-time in its own patient way, whether you are awake to watch it or not. Right now, you do not have to be productive. You do not have to be strong. You do not have to be on. You only have to rest. Thank you for spending this time with Midnight Lab. Whenever you need another quiet journey among the stars, you are always welcome to come back. For now, let gravity hold you gently, let the day slip farther away, and let your mind grow quiet. Good night. Sleep well.